Good afternoon, and thank you for the participation in that session. My name is Pawel Skrzypek. I'm representing the Seven Bulls company, NebulOuS project. And yeah, first thing, thank you, Mark, for invitation. Great to be here. And that's the very nice opportunity to tell you about something slightly different. Yeah, so maybe it will be not the typical some tools or programming demo presentation, but I would like to tell you about the NebulOuS meta operating system, which is based on the Kubernetes. Yeah? The unique thing regarding that stuff is that it's not a typical open source or software project, but this is the project developed within the Horizon Europe research project funded by the European Union. I'm not aware if you are familiar with that type of the project, but there is a huge number and huge development research regarding the software architecture and building the new and innovative things within the European Union, Europe generally, because UK also participate in that project. And there are a lot of the very innovative stuff which is not properly popularized. Yeah, so the developers, architects, DevOps usually have a little knowledge about that, if any. Yeah. So I'm happy to have that opportunity to share with you this project. Maybe that could be some inspiration for you. And also at the end, I will tell about one opportunity which is possible within this project for the use case application to get funded and to test the developed software. Yeah, so that's a bit introduction about the vision of the project. Yeah, the vision generally is quite bold. So the idea is to build the meta operating systems based on the Kubernetes, which will cover the cloud continuum, multi-cloud operation across different cloud providers, across different other venues, yeah. And the goal is to be able to deploy application both to the cloud devices, to the IoT and fog. And yeah, even more, I will tell about this a bit later. This is currently developed by 12 organizations. It is the academic research units from Europe, companies, and 4 use case application. I will show them at the end as well. Yeah. What are the goals? Yeah, the goals are multiple goals. Yeah, first goal is to provide the provisioning tools. So the idea is to have additional layer to cover the complexity of the different cloud providers, different types of the deployments, so cloud deployment, IoT deployment, and so on. Generally speaking, the idea is to cover the cloud continuum. I will tell a little bit more about that later. And to build the meta operating system. So the one system which rules all of them. Yeah. So that's the reason that I said that the vision is bold, but yeah, I think it's the way to move forward. Yeah. The unique feature of the NebulOuS is also the ability to compare the offer from the different cloud providers. Yeah, so that's the built-in optimization engine. And also the unique thing is the covering the SLA using the smart contract. So the idea is that the providers provide the services and the SLA is based on some kind of the smart contracts at their own based. Yeah. And obviously this type of stuff needs to cover the security in terms of the access and networking. The general idea is quite simple, yeah, to allow the to make the deployment easier, yeah, to make it more automated, so it's perfectly in line with the today's and yesterday's presentations, and to spread it across the cloud continuum to make it easier to work, yeah, because as you perfectly know, the deployment to the one cloud provider is slightly different than to the another cloud provider. The deployment to the IoT, Raspberry, and this type of stuff is a completely different thing. Yeah. And NebulOuS is a way to automate that and to make it working. As it is a research project, so I will start with the definition. Yeah, what is the cloud continuum? And the definition is generally very simple because it's a cloud, edge, fog, including the other mixes of the clouds. Yeah, and I am pretty sure that many of your application is working across the cloud continuum. Yeah, so we have the application on the mobile phones in the cloud. For the 5G, there are a lot of the application which are working on Macs, yeah, close to border of the network, and in the cloud computing. I will show also some examples here. Yeah. But also the simple question, why we want to use the cloud continuum? Yeah, the cloud is great, we can stay in the cloud, and that's all about that. Yeah, but it doesn't work that way, yeah, because the data is generated maybe not only, but usually outside of the cloud. Yeah? Users are generating data, users accessing the systems in the different way. There are a lot of the sensor IoT devices, and there is the exponential growth of these devices, and all of this is done outside of the cloud. Obviously, we need to have all of this data into the cloud, but we need to properly generate that data on these devices, store this data, and we need to have multiple layers of storing this data, finally in the cloud, but it's not immediate process. We need to transfer this data, and finally we need to process this data, and processing of the data, I'm pretty sure that you are also aware of that. It's usually split between the different stages. Yeah, some of the data could be processed on the IoT devices, on the smartphone, and so on. Some of them requires a lot of much power and needs to be processed in the cloud. There are also a lot of the constraints, yeah, technical constraints like network throughput, network latency, yeah, security, the need for the specialized hardware. That's some technical constraints, but there are also non-technical constraints. Yeah, we need to be aware, especially in Europe, about the regulation regarding data processing, data ownership, and to be compliant with the existing standards. And yeah, in fact, in the NebulOuS, we plan to address at least some of that. Yeah, and yeah, just to be on the same side, this cloud continuum, obviously it's a public cloud, but there are also a lot of the private data centers, especially big companies are still using the private data centers, and that the huge deployments there. We have also private cloud edges, so this also called micro data centers, especially 5G operators, 6G operators are creating them. And we have also the IoT devices, which becomes more and more powerful. Yeah. Obviously, before the cloud continuum, there were a lot of the different names for the cloud. Yeah, we have the multi-cloud, which is probably the most typical way of the cloud deployment. So we have just simply two or more cloud providers. Yeah, and that's the first step. Yeah, we don't want to be fully dependent on the one cloud provider, or at least to have the whole system in the one region, but we would like to deploy across at least regions, but ideally through the different cloud providers. We also have the hybrid clouds, which becomes more popular, at least according to my knowledge, becomes more and more popular last time because it's a more cost effective, yeah, especially for the AI task processing. That's much more cost effective than cloud, yeah. And Cloud Continuum is just the matching all of that into the one thing. Also some definition very quickly, what is the meta operating system? So the idea is to create something like the operating systems, Linux or SOAP, but distributed. Yeah? So ideally we are deploying the application to that meta operating system, which take care about distribution, finding the most efficient way of setting the resources and run the application. Yeah? That's the vision and idea. And NebulOuS is covering the most of the feature of the operating system. So there is a unified management of the application. There is advanced brokerage between the different resources. So using the NebulOuS, you can deploy the Kubernetes cluster very easily to the different cloud providers like AWS, Azure, or have it on premises on the OpenStack and deploy to the cloud. Part of the NebulOuS is the distributed event management system. So we're collecting the metrics from the application and based on that make decision and deploy accordingly. Part of the NebulOuS is also the secure networking because if we are deploying across the cloud, we need to be secure. And there are also the role-based access system. Last but not least, the user interface to operate the whole. That's the architecture. So the core of the NebulOuS is this broker, fog broker. So that's the component which fetch all of the offerings from the cloud providers. So just simply speaking, what is the cost of the given virtual machine? And decide how to deploy the application on the Kubernetes cluster. And yeah, very interesting things of the NebulOuS is that it could add the Kubernetes workers, Kubernetes pod to the cluster and distribute that. So thanks to that, this cluster could be dynamically managed. Yeah. And we have also this SLA based on the smart contracts, which is quite unique thing, yeah, because it's non-repudiable, yeah. So nobody can say that it doesn't happen, yeah. If the current SLO is published, it is not possible to change it backwards. And the idea is to have the whole intelligent management of the application across the whole system. So the key features of the NebulOuS are the first thing is the tools for the modeling application, because the current tools needs to be extended and we are using the kubevela for the application description, which is very common, but with the additional tags and additional features to support that. We have fully built the multi-criteria resource broker, so we can select the resources based not only on the cost, but for example, on the SLA parameters, on the performance, availability, and so on. And this is the smart contract-based service level. Yeah, we really believe that it's the way to go between the cloud providers, but it's just a first implementation. And we have the reactive and proactive reconfiguration of the application based on the metrics and the built-in optimizer. So for the modeling, as I said, the kubevela was quite extended to be able to include the application topology, the service level objective into that, and optimization criteria. It's a very well described and quite natural in the kubevela. It's very easy to learn that if kubevela modeling language. The multi-criteria resource brokerage is mostly self-working systems, so it's fetch the offers and make a decision based on the criteria defined in the kubevela. Smart contract is also self-working. Currently, we don't have the providers which support this smart contract version of the SLO and SLA, but I hope in the future it could be deployed. It's definitely very interesting idea to manage the SLA and SLO, which I didn't see yet. Yeah. And reactive and proactive reconfiguration of their application based on the metrics. All of the cloud providers have this feature, so you can scale up and down the application based on the metrics, but usually within one cloud provider. Yeah, here we are covering multiple providers and could scale across the cloud providers. And last thing is the security, which is obvious for the multi-cloud deployment. And in our case, there are three pillars. Yeah? One are the isolated Kubernetes clusters. Second are secure virtual network, which is built between the workers of the Kubernetes. And last thing is centralized role-based access control. And yeah, this type of the application, this type of the system is not for the all application, because there is no point to use this system for the centralized application, which could be deployed to the data center or to the cloud. It's spread that the system is for the application which are using this cloud continuum. So usually the IoT-based devices. And here I would like to tell a little bit about these 5 use cases. These 5 use cases are native use cases of the NebulOuS project, but within the project there are open calls when there is a possibility to recruit new use cases. One batch of these open calls was already done, and some use cases were recruited, but the next is currently in progress. So if you find that interesting, it's the possibility to apply. But going back to the native use cases, first is the windmill maintenance, and it's a very novel application of the windmill, electricity producing windmills using the drones, yeah, because usually these windmills are far from the civilization, like offshore farms and so on. So the inspection of these windmills is very difficult, and the typical way is that the truck with the drones is going to that place when the windmills are, and the inspection is done by the drones because these windmills are usually huge. And these drones are making videos, making a lot of the photos, and these photos needs to be processed to find the damages and so on. That's the perfect application for this cloud continuum deployment, because some of the processing is done on the drone, some of the processing is done on the edge devices, which is the computer laptop of the operators. All of these drones are sending the video and pictures to this laptop, and there are some processing, but final processing is done in the cloud. Yeah, so this is the full cloud continuum, and yeah, it works very well. Yeah, before the NebulOuS, this type of the application requires to make a separate deployment on the drone, separate application on the laptop, and separate deployment to the cloud. With the NebulOuS, it could be automatically covers all of these 3 steps. The second use case is the computer vision. It's the monitoring in Barcelona. It's a company, UBWare, who is handling the city monitoring in Barcelona. Yeah, we have a lot of the data sources from the cameras, and the idea is to have the real-time or the near real-time identification what is happening. If there are car accidents or car congestions, traffic jams, and so on, to identify that and to make the reaction, to change the lights, traffic lights, or to let the proper services know that there are the issues. And this application, there are a huge of the number of the components, because there are the components in each camera, small components, which is making the first screening of the video stream. And this application is also perfect examples how this cloud continuum should be used. The third application is the precision agriculture. It's done by the company from Greek, and it's a very interesting approach of applying the new technologies to the agriculture. They have a sensor in each tractor, in each farming device, and collect a lot of the data from the fields. We are talking about the industry farming, not small farming, but industry farming. And these data are processed in the similar way as for the windmills. So there are edge devices like computers, laptops, and finally all data are processed by the cloud. The third application is the fresh food supply. That's again for the Barcelona. It's a delivery to the fresh food to the shops and other stores in the Barcelona. And it also requires to have the real-time tracking and making a decision process. And the last application, this is from Germany. It's a crisis management. So the operation of the crisis teams, they have the special name in case of fire, flood, or that stuff. It's a The one of the German company built system to manage that type of the operations, so the crisis management. So each of this crisis team, is very well digitalized. Yeah, they have the smartphone application and could provide the data. But the idea is to properly process this data, gather and deliver to the command center as quickly as possible, ideally in the real time. So that application is also a perfect example how this cloud continuum is used and what are the benefits of the NebulOuS. Yeah, first version of the NebulOuS was deployed during some floods in South Germany. Yeah, and they are very active users of that applications. Okay, and last thing, yeah, because time is going. As I said, yeah, the project have these native use cases, which I briefly described, but there are also possibility to recruit new use case applications. So if any of the audience have the application which is using Cloud Continuum, there is a second batch of the NebulOuS Open Cloud, the NebulOuS Open Calls, so you can apply for that and use NebulOuS, yeah, test NebulOuS and get some funding for doing these tests, yeah. So that is currently in progress. Here is the link, yeah, to this open calls. So please, yeah, if you are interested and if you find it useful for your application, there is this opportunity. And yeah, also I would be very happy if more developers will start being at least aware of this European research project, because that's the lot of the work, which, yeah, gives some very innovative ideas, but it's not spread to the developers and not properly disseminate to the developers. That's a really pity. So, Mark, again, thank you for inviting for this conference and being able to present.
Absolute pleasure. Thank you for being with us. Any questions?
Thank you, great talk. I would have a question about the smart contracts and when it comes to SLAs. Do I understand correctly that this is solving the trust issue between the provider, the service provider, and the service consumer? And could you just a little bit elaborate on that, because it's really new, at least for me, and it would be nice to hear what it is about, what is the technical foundation it builds upon, and how it actually just works.
Yeah, thank you for that question. And the idea is exactly as you said, yeah, to build some of the trust, yeah, because with the SLO looks greatly on the presentation. Yeah, we have the metrics and the metrics are measured and we are happy with these metrics. But if we have the provider and we have the customer, and provider is calculating these metrics in the way to be as optimal for him, yeah, to not pay penalties or not get discounts, and customer is really know what the metrics is because his application is suffering in case of the low SLO. And the idea is to make a smart contract based on the Ethereum, where we have the definition of the given metric like availability or latency or response time. Both parties, I agree, both on the value of the metrics and the way how it is calculated. Yeah, it's very important that it needs to be calculated fully automatically, because thanks to that, it's objective or somehow objective. So in this smart contract, we have these two things, yeah, the value and the way of the calculation. And then the metrics are collected, calculated, put to these smart contracts, and each of the parties automatically confirms, yeah, that the SLO is given for the given moment. And if it's confirmed by all parties, it's written in the blockchain to know that for this day we have the SLO at this level. And thanks to that, we have non-repudiable history of these metrics, so nobody could backwards change that, update that, or do anything like that. And at the end of the month, we can calculate, okay, that SLO was at this point, yeah. We have all of the information in the blockchain, non-repudiable, agreed and confirmed by both parties. Yeah, so that's exactly that's idea.
All right. Thank you so much. More questions in the lobby.
Thank you very much. Thank you.